A-Level Physics 1993, question 19. Here we see a graph showing the resistance variation with the temperature of the resistor. The resistance is not varying a straight line, but instead is varying on the curve. Therefore, when we look at the resistance thermometer, we'll think that this is an inaccurate value when compared to the other value obtained by a constant volume gas thermometer, which we are taking it as an accurate value. So when we use the resistance as a reference to take the temperature, we are actually applying this equation for a thermometer. And when we use this equation, we have a crucial assumption. That is, we assume that the resistance is varying along a straight line, but in fact it is not. However, when we use this equation for calculation, what we are assuming is that the resistance of the resistor will vary like this. However, this is inaccurate. Okay, but this is used in our calculation. On the other hand, for the line given in black, it is the accurate variation of resistance versus the temperature. So this is the actual variation. So we obtain a reading in the second paragraph. We see that it is said that the resistance thermometer gives a reading of 1.28 ohm. So you can see 1.2 is here, 1.3 is here, 1.28 will be here. So the resistance is measured to be 1.28. So in our calculation, we'll look at the red line, which we think it is the variation. So we'll draw a horizontal line from this point 1.28 until it reaches the calibration curve, and then we will draw a horizontal line, and then we will take the temperature. The temperature we thought would be 20 degrees Celsius. This is when we are applying this formula. We'll get a temperature reading of 20 degrees Celsius. But in fact, the variation of resistance versus temperature is not a straight line. So when we look at the actual variation of temperature, 1.28 ohm will point to this point. And when we try to take the reading by drawing a vertical line from this point, it gives us a temperature reading of 36. So 20 degrees is what we thought it is, but 36 is the actual temperature. 20 is inaccurate, and 36 is the accurate reading. Therefore, when we look at the first column, saying that the room temperature on the resistance thermometer, that means the inaccurate reading, will have a reading of 20. Whereas, when we look at the room temperature on the gas thermometer scale, which is the actual and accurate temperature reading, will have